Okay. Now let's try again. Okay. 2x plus 4 is 9, right? That's our equation. We subtract 4 from both sides because that's going to get rid of this 4, right? We don't move 4 over here. You can think, I want to move 4 over there, but make sure you know how to move 4 over there, right? You subtract it from both sides, and that's a step that I want to see in your work, because it means that you're thinking through the rules rather than through conditioning. And we're teaching you to think, or we're just conditioning you to, you know, whatever. Okay, so we subtract 4 from both sides. You get 2x plus 4. Yeah, you can read it, you know. 4 subtracted from this side, 4 subtracted from this side. And that leaves us 2x over here and then 5 over here. Then you got 2x, and you're going to divide that by 2, because 2 divided by 2 is 1, and 1 times x is x. Okay? And of course, you got to divide this side by 2, so that gives you 5 halves. And then you have x equals 5 halves. Now, so well, we substitute 5 halves back into this equation, right? Okay, what you get, I'll write it down here kind of small, but you think you can tell what I'm doing. You get 2 times 5 halves plus 4 equals 9, right? Well, 2 times 5 halves is the same as 2 over 1 times 5 over 2. Okay? And you're multiplying fractions. So that gives you 2 times 5 over 1 times 2 plus 4 equals 9. I'm almost afraid to take this thing away. I'm afraid the camera will go out of focus. I think maybe we have enough stuff up here. Okay. Now, can everybody see that well enough to see what I'm doing? Because I'm writing kind of small. Okay, well, what's 2 times 5? That's 10 divided by 2. Okay. 10 divided by 2 is 5. There's a big check mark there because it checks out. It gives us a true statement. Okay. Now, another way to look at this is let's just look at the fraction. 2 times 1 times 5 over 2 equals 2 over 2 times 5 over 5. It doesn't. 2 over 2 times 5 over 1. I don't know what I just said, but it was as bad as what I wrote. Okay? Because 2 times 5, you know, when you multiply these out, you're still going to get 10 over 2, right? But you don't have to multiply out to get the 10. 2 divided by 2 is 1. That's 1 times 5 over 1, and that's just 5, right? So I can rearrange this multiplication to have the 2 divided by the 2 and the 5 divided by the 1. So when you see 2 times 5 over 2, you should think, well, okay, that's 2 over 1 times 5 over 2. That'd be the same as 2 over 2 times 5 over 1. It would give me the same product when I multiply it out. The numerator would be to have the same numbers. The denominator would have the same numbers. That's a little bit complicated, but algebra gets more complicated than that. And that's why you can cancel the 2. Okay? Now the problem is, there are other places where it looks like you ought to be able to cancel, but you can't. Okay? And I'm not going to address that just yet. Okay, anyhow. It's actually along with the check down here, right? Okay. I'm going to erase this part. I'm probably going to need the room. I probably didn't leave myself enough room to start with. All right, let's see. Actually, this one's pretty quick, okay? 3 times the quantity of 4 plus 2 equals 4. We want to use the distributive law. We're going to read about the distributive law. Open Math is going to talk about the distributive law, okay? So you're going to see plenty of distributive law. You're going to have to use it, but it's pretty easy. The 2 times 3, quantity 3 plus 2 means 3 multiplied by the x and 3 multiplied by the 2, right? So that's just 3x. That's 3 times 2 equals 4. And you want to write that stuff out because you want to be used to thinking this times this plus this times this. Don't just write out 3x plus 6. It takes about 4 seconds to write this out. Write it out. Because it reminds you of what the rules are and what the process is. So when you get to more extensive equations and more complicated equations, you won't be shortcutting in a way that causes you missing. Okay? Now, there aren't that many rules, but sometimes it can be tricky to apply them. Okay? So 3x plus 6 equals 4 then. 3x plus 6 minus 6 equals 4 minus 6. So that 3x equals negative 2. 3x over 3 equals negative 2 over 3. And it's just like 2x over 2. The 3 divides the 3. It's 3 over 3 times x over 1, if you like. That's what you would have if you broke this into 2 fractions. And 3 over 3 is 1. X over 1 is x, and 1 times x is x. So you do that in your head, and you should. And you should write that out a few times at least to convince yourself that you really know it. And if I see that, then I worry about you much less. Okay? And your whole goal in life is not to worry me. And you didn't know that until right now, but that's it. Okay? Don't worry me. Okay, well, maybe that's your goal, maybe it isn't. Probably not. Okay, probably shouldn't be. Okay, 4 times 3x plus 2. The quantity 3x plus 2, that's, I'm going to write it out. 4 times 3x plus 4 times 2, just to keep reminding ourselves about the distributive law, equals 5 times 4x minus 5 times 3. Doesn't take long to write it out. Okay? After you've written this out about 50 times, then probably don't need to write it out anymore because it'll probably be ingrained. Okay? And you'll know what to do by looking at it. And you'll also know why that's the distributive law. So if you're not sure if you did it right, you can think back and say, well, yeah, okay, there's the law, and that's what I just did. Instead of, I think I got it right, let's just go on and hope. Sometimes you got to do that, of course. Try to avoid it whenever you can. So you got 12x plus 8 equals 20x minus 15. Okay? Now what are you going to do? Well, you want x's on this side and numbers on this side because that's what you want to see so that you can do this last step, right? See? So you're going to say, okay, well, we'll do this in 2 steps. We'll do 12x plus 8 minus 8 equals, 20x, no. Yeah, never mind. 20x, there are 2 ways you can do this. I just confused myself for a minute, but there we got it, okay? Subtract 8 from both sides. A little circle around that minus 8 here and that minus 8 here. So you can see this side's the same as this one except for this, and this side's the same as this except for this. And there's an x on that 12. Okay. So what you should have been doing there is jumping up and down the okay. Yeah. So we're going to say, okay, so now 12x equals 20x. And of course, negative 15 and negative 8 is negative 23. Right? Now, what are we going to do about this? We got X here and X here. We want all the X's on this side. Well, then you say, okay, well, we're going to subtract 20X from both sides. And then 20X minus 20X is 0, so you end up with negative 23. 12X minus 20X is negative 8X. Okay. And then we divide both sides by whatever's in front of X. In this case, what's in front of X is negative 8. So we have so finally X equals (23/8). Okay. Okay. Now, thanks for explaining yourself. Okay, so it's possible that you subtract the X off first, which is going to put the X's on this side. So instead of negative 8X equals negative 23, you have negative 23 equals negative 8X. Okay, so you could have ended up with the answer 23/8 equals X. Okay, this is identical to this because it doesn't matter which side which is on as long as they're both the same. Okay, it's called the reflexive law of equality. Reflexive laws are a big deal in more abstract mathematics. But let you deal with that when you get there. So you would generally then want to write this as X equals because you want to see what X equals. Okay, but it's not wrong. If you write this down as your answer, I'll complain about it a little bit. Say, hey, you really should put that around, but I'm not really complaining. It's a good answer. Okay, but if you want to exist in polite mathematical society, you write X equals. Okay, whether it ends up that way or not, if it ends up with X on the right-hand side, you generally want to turn it around. Let's say I've got X over 8 plus 5 equals 7. Okay? Now, raise your hand. Don't say anything. Raise your hand if you'd rather not work with fractions. Most people would rather not work. I'd rather not work with fractions, although I'm pretty good at working with them. I'm less likely to make a mistake if I'm not working with fractions. Okay, sometimes you can't avoid it. You got to add 2 fractions. You got to add 2 fractions. You got to simplify a complex fraction. You got to simplify a complex fraction. But in this case, you can avoid the heck out of it, and you want to, because all you have to do is multiply both sides by 8. Okay. This gives you 8 times X over 8. That's 8 times 5 equals 56. Well, what's 8 times X over 8? You hold up your hand. That's X, right? So now we've got X plus 40 equals 56. And you know what to do from there, so I don't even have to bother with it. What we've done by multiplying by that denominator is we've cleared out fractions. And now we just have an equation that's every bit as simple as the ones that we just looked at. One of the simpler ones that we just looked at, the first one. We end up with this, right? That's really easy. Okay, so let's try this one. I'm going to stretch it a little bit. Let's have you see what you can do with this one. And if you're not getting a start on it, I'll help get you started. But let's look at what I did. and you probably figure it out. Okay, so we need a little room to do this. I'm going to start over here. Okay, multiply both sides by 5. So this gives you 5 times x plus 2 over 5. I think everybody got. Okay, well, minus 15. And of course, the 5 is multiplied by the 9 here. Don't be careless like me. Okay, so 5 times 9 is 45, right? Okay. Now, take this expression here. X plus 5. 5 times x plus 5 over 5 means this, right? So let's go back to what the expression means. And make sure that what you get is consistent with that. 5 divided by 5 is 1. Make sense? So that this is this, and this is then just going to be x plus 2. Okay, so x plus 2 minus 15, of course, is x minus 13. So you get x equals 58. So you got that intermediate step, x minus 13 plus 13 equals 45 plus 13. See, I wrote it out. You can't read it. At least I wrote it out. Okay. And if you got to insert it in there, you realize you left it out. I don't care if it's written kind of small. If I see that you've done it, even if I can't read it, say for the copy you send me, I'm pretty sure that you did it. Okay. And then again, you're moving closer to accomplishing your goal of not worrying me. Okay? Okay. Okay, camera kind of went out of focus there. Let's make sure you see everything that we did over here. In case it was blurry over there, I didn't look. Okay, we got 3 equations in symbols. Okay, these are now going to be numbers. X, P, Q, H, K, and R are just symbols. They stand for numbers, but they might stand for different numbers at different times. So you want to get a solution for X on each of these. Okay. On this one, solving for X. It's just like this problem here, where we start by subtracting the 4 from both sides, right? Excuse me. So we subtract H from both sides because we're solving for X. That's close. Sorry. Close. I almost started dancing. Okay. Went to the gym yesterday. I'm a little stiff, so I managed to restrain myself. But it wasn't going to last long. Okay, good. Okay, so X plus H minus H. Well, H minus H is 0, right? I'm going to write that out explicitly. You don't really have to write this out, but you want to think it. And it doesn't hurt to write it out. X plus 0 equals this, so that X equals F minus H, right? Now that's complete detail, okay? And again, more or less optional to do this. You can see that that's 0, but it's a good idea to write it out at least a few times. Again, to remind yourself, okay, P times X equals B. Well, I just divide both sides by 2, just like I would do if I had 2x equals 5, I'd divide both sides by 2, trying to solve for x, right? So is that p times x over p equals b over p. And since p over p equals 1, we'd have then x equals b over p. B over P. I get a 5 out of that. There are no numbers here in my visual field. And I never know what my hand's going to do. Okay. Got it? Okay, now, on this one, there are a whole slew of ways you can solve this problem. Okay? I think the most efficient way is to say, okay, I've got Q, X, minus E8 using the distributive law. So that gets the x out of the parentheses here where you can deal with it, right? Okay. Plus k equals r. Pretty simple, right? Okay, now I'm going to do it at this stage. There are a number of things you can do, and you'll manage to invent several. And usually they were valid, okay? Sometimes they led to some subsequent mistakes where you lost track of the term or something. So you want to do this in the most efficient way. I think the most efficient way to do this, but maybe not the cleverest thing that I've seen, is just to grind through it and say, okay, there's my x, everything else better end up on the other side using the rules. And the rules are, boy, that's a bad looking cube. That was a Q. Romans would have killed it at birth. Okay. Get a little bit long there. I've got to separate the 2 lines. But you see what I've done? I've added QH so that the negative QH and the QH would give you 0, right? And I've subtracted K because I had a K here, K minus K. And then, of course, on this side, I did the same thing. So I just kind of circle the thing I did on both sides. I think you all are in good shape to understand that. Then, of course, all this adds up to 0. So just end up with Qx equals R plus QH minus K. I'm getting stuff too close together here. But I think you can see what I've done. And then I divide both sides by Q. So I'm going to cheat and bring this back here and say, okay, well, then Qx over Q equals R plus QH minus K over Q. So that this is going to give you X. It's going to give you this, right? Now I want more board space here. Okay. Okay, so I'm going to do it like this. I'm going to say, okay, we start with the equation Q times X minus H plus K equals R. Dots, because I've already done the steps, gets us down to Qx over Q equals R plus QH minus K over Q. And of course, this gives you X because it's Q over Q, which is 1 multiplied by X, right? This is X. And now I can write this out in 3 terms. because when I divide by Q, it's like I multiply by 1 over Q. Just a multiplication, so it's like a distributive law, right? It is a distributive law. So division by Q actually distributes, just like multiplication by Q would distribute, because division is just multiplication by the reciprocal. And I get R over Q plus QH over Q minus K over Q. Now, this simplifies because I've got a Q here and a Q here, right? So there is one form of the solution. Now, sometimes you would want the solution in this form. This form. I never did write out this form with x equals this, but sometimes people might just say x equals all this. Okay, one fraction expression. So let me rewrite this the way I. Did I have that written down? I don't know. Okay. My visual field gets confused by the mask sometimes. I don't really notice it's there. There's stuff I don't see. So it might have been there. I just didn't see it. Causes a problem when I'm walking the dog. It pulls me up over rocky cliffs. And I need my depth perception to see where to put my foot. And I think I have it, but I don't. Okay. So eventually I'm going to erode those cliffs away by falling off of them. Okay, well, anyhow, not really cliffs. Uneven ground. Okay, exaggerating. Okay, so anyhow, there we have it, right? Makes sense? Okay. Now, there's often a temptation See this? Yeah. This is why I don't like cancellation, because you see this and you see this, you cross them out and you go on, and you got something that's completely wrong. Very, very wrong. Okay. Okay, so we don't do that. And we don't use cancellation until we're really sure we understand the rules. Because most people coming into a pre-calculus class would be, or even a calculus class, would be very hard pressed to explain why you can't do that. Okay, now, it's a lost equation. Make sure I'm writing it out here. Q times x minus 8 plus k equals r. Now, really the quick solution is, okay, well, let's just keep this here. Okay, so you keep this factored. You don't use a distributive law immediately. Okay. Then you divide both sides by Q. Right. Then Q divided by Q is Q, is 1. And that just gives you X minus H equals R minus K over Q. So that X minus H plus H equals R minus K over Q plus H. And I'm starting to write really badly here, sorry. Okay, which gives you X equals R minus K over Q plus H. Now that's a really good solution. And it's a good form. Now we put it into this form by doing R over Q minus K over Q, right? And then we have our H here, so it's totally equivalent. So that's just one example of how you get a different form. It's still valid using different steps. And really that's a more efficient solution than the one I did. But I wanted to build the one I did on the kind of order of the rules I gave you. Okay. And I really like this. I like some of the others, that's what too. Okay. So many ways to work through these problems. As long as you stick with the rules, you're good.